All right, so our next learning objective goes back to dealing with square roots. I will end up using this to help us with quadratics in a bit, but we have to learn something before that. So we're going to talk about simplifying square roots, and there's kind of 3 different things we'll have to learn in this one learning objective. All right, so first, we already learned about square roots. It's the number you multiply by itself to get the number. So the square root of 4 is 2, because 2 times 2 is 4. All right, so that's why the square root of 4 is equal to 2. All right, the square root of the square root of 25 is 5, because 5 times 5 is 25. All right, but this isn't always going to work out exactly like this. For instance, if I want to take the square root of 5, there's no nice whole number that when I multiply it by itself gives 5. All right, so how can we simplify square roots that don't come out to just a really nice answer at the end? And the answer is that we say a square root is fully simplified, so we can't kind of make it simpler, is if there's no perfect squares left inside the square root. So perfect squares are numbers that are exactly a number multiplied by itself. So the kind of starting ones are 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6, 7, 8, let's just go up to 10, 9, 10. All right, so those are kind of the starting perfect square roots. It keeps going. You could have 11 times 11, 12 times 12. All right, but if any of these numbers divide what is inside your square root, then that means you can simplify it. All right, so friends, if I want to do the square root of 8, again, you could even check that if you put the square root of 8 into a calculator, it's not going to come out as a nice even number. All right, it's going to give you some decimal that's kind of close to 3. All right, but how can you do this simplifying it? Is, again, you're just going to go through those numbers that we had, 1, keep writing it, the thing, 1, 4, 9, 16, and so on, and see if any of those divide your number in your square root. And it turns out it does. 4 divides 8. So what I can do is I can separate this out. 8 is 4 times 2. That's perfectly legal. I haven't really done anything. I've just broken up 8. Nothing's gone out of the square root yet. But what I do know is the square root of 4 is a nice number. So the square root of 4 can pass through the square root. And when it does, I take the square root of 4, which we saw on the last slide is 2. So as this 4 goes through the square root, it becomes a 2, again, because 2 times 2 is 4. This 2, I can't pass through the square root as a nice number because it's not a perfect square, so it just stays inside the square root. So the square root of 8 simplified is just 2 times the square root of 2. All right, so for all of these, what you're going to do is just kind of go through and see if any of those perfect squares, and I'll kind of keep writing them down for now, any of these perfect squares divide that number that you're looking at. All right, and you might be able to do it in small bits. So the first thing I can see is that 74 is divisible by 4. So 72. 72 is 4 times 18. And again, the 4 can go through the square root and it becomes a 2. All right, but again, your square root's not fully simplified until there's no perfect squares left, but I still have a perfect square because I know that 18 is 9 times 2. And the 9 is a perfect square, so it can pass through and it becomes a 3. So now I have this 2 and this 3 on the outside, that's going to become a 6. All right, so my final answer of this one is 6 squared root of 2. And it's not always going to be a 2 in the parentheses, just the first 2 examples worked out that way. And there's also multiple ways you can do these problems sometimes. So this one I figured out there was a 4 and a 9. You also could have figured out at the start that the square root of 72 is 36 times 2. And then just done, the square root of 36 is 6. All right, so there's multiple different ways to get to the final answer. But you know what your final answer is if this number, all right, the number that's left in the square root, is not divisible by any of our perfect squares. All right, one more example. We're trying to find the square root of 1152. All right, so again, I'm always just going to, especially for these big ones, I'm just going to start at 4 and see if I can make it smaller. So 1152, I'm using a calculator to do this. 1152 divided by 4 is 288. So I can bring out a 4, and that's going to turn it into 2 square root of 288. And I see, okay, well, 288, is that divisible by 4? And it is, so I'm going to do it again. 4 times 72. And that 4 comes out as a 2. Oops, if I can And 72 we actually just did. 72 is 36 times 2. So that's going to come out as a 6. And I have all of these numbers out in front. So I have 2 times 2 times 6 is 24. So 24 square root of 2. And I guess I made a mistake making these problems. All right, not all of them will have a 2 left over, just all 3 of these examples did. But as long as that number is not divisible by those perfect squares, then this is your final answer. And this also means we could have done this in a bunch of different ways. You could have figured out that 1152 is divisible by 144, which is 12 times 12. You could also figure it out that it's divisible by 576, which is 24 times 24. All right, so there's a lot of different ways to do this, but I generally just kind of start, can I divide it by 4? That's the first perfect square. Can I do 9, 16, that type of thing? All right, and then as long as you keep going until you have no perfect squares left in your square root, then it's fully simplified. All right, so here's one for you to try on your own, the square root of 200. All right, and you get 10 square root of 2, because 200 is 100 times 2, and the 100 goes to the square root and becomes a 10. And again, there's other ways you could do it, but as long as you have your final answer as 10 square root of 2, that's the correct final answer. And again, once again, it's not always going to be a 2 for some reason. Just all the examples that I made up have a 2 there. All right, so now we're going to do the same thing, but with variables. So that, again, with variables and numbers, generally you kind of separate them out into 2 parts. So the number part, the square root of 20, let's kind of do it to the side here. Oops. Square root of 20. Let's see, 20 is divisible by 4. It's 4 times 5. And the 4 becomes a 2. All right, so this is finally one where there's not a 2 left in the square root. All right, so 2 square root of 5 is the number part, and let's do the x cubed part. When we did this in a previous learning objective, basically you just divided the exponent by 2, but 3 is not easily divisible by 2. Right, let's think about x cubed is 3 copies of x. All the even ones can come out nicely. These 2 x's, when it comes to the square root, is just going to become a single x. And this 1 doesn't have a pair with it, so it just gets left in the square root. So when I put all this together, the stuff outside the square root is this 2 from the number part and this x from the variable part. And inside the square root, we have the 5 from the number part and the x left over from the variable part. So the simplified version of this is 2x times the square root of 5x. All right, another example, square root of 36x to the 7th. Again, the number part in this case is going to be really nice. The square root of 36 is just 6. But the variable part, we have 7 x's, 2, 3, 4, 5, 6, 7. And you'll start to see a pattern is that, again, we're looking at the even part of it. So we have 7. The even part, which is going to go through the square root nicely, is 6. And then when we take the square root of x to the 6, we break that in half to get x cubed. So we're going to have an x cubed that comes out. But this 1x here is going to be left inside the square root. All right, so the general thing you're going to do is if this number is odd, you're going to subtract 1, right, and that 1 is going to be left over inside the square root. And the leftover part, the even part, you just split in half to get that exponent there. Right, but if you kind of just think about what part can you bring out of the square root nicely, what gets left in the square root, the same thing happens. Right, so here's one for you to try on your own, the square root of 27x to the 5th. And here's the answer. So the 27 part is 9 times 3, so the 9 comes out as a 3. It gives us 3 square root of 3. The x to the 5th part, again, you look at the even part, the biggest even part, so we have x to the 4th, and that kind of 1 extra x. And we saw when we take the square root of x to the 4th, we basically just divide that exponent by 2, and that 1x stays in there. So putting it all together gives us our final answer, 3x squared times the square root of 3x. All right, so this is how we simplify square roots when there's numbers and variables mixed together. And the very last thing we have to talk about in terms of simplifying square roots is that, and it kind of doesn't seem like it should be there, but it's just kind of a way to make sure everyone's kind of final answer looks the same, kind of like order of operations. All right, the rule is that there should not be a square root in the denominator of a fraction. So if we have a square root in the bottom of a fraction, we need to kind of get rid of that and make our fraction look a little bit different. We can always change the way a fraction looks by multiplying the top and bottom by the same thing. And the way we're going to do it in this case is multiply it by the square root that's giving us an issue. In this process of making sure the bottom of the denominator does not have a square root is called rationalizing the denominator. Not something you really have to know fully, but if you're reading a book or something, you might see rationalizing the denominator. That just means making sure there's not a square root on the bottom. All right, so how do we do this? Again, we see there's a square root on the bottom of our fraction, so our answer is not fully simplified. All right, so what I'm going to do is multiply my fraction by that square root over itself. So the top's going to become 3 squared root of 8 because you just multiply. And the reason we do this, when you multiply a square root by itself, square roots are all about multiplying things by themselves. When you multiply the square roots by themselves, they actually just cancel out, and I get whatever number was inside the square root. All right, so that's all you have to do to rationalize the denominator. Multiply the top and bottom of the fraction by whatever square root is giving you a problem. And then for this one, we can actually go a bit farther. We saw earlier that the square root of 8 is 2 squared root of 2. It's going to be 6 squared root of 2 over 8. And then the top term is even and the bottom term is even. All right, so I'm going to be able to rewrite this as 3 squared root of 2 over 4. All right, one important thing when you're kind of simplifying fractions, all right, this is one whole term. You have 6 square roots of 2. So when you divide it by 2, only the 6 is going to get divided by 2 because like the square roots are separate. All right, so you just divide that by 2. And again, we're dividing the bottom by 2 to get 4. All right, so oversimplifying the square roots is one issue students will make. All right, but I technically would accept this final answer. But if you recognize both things are even, you can get that final answer. All right, simplify 5 over the square root of 32. Again, the first step I'm just going to do is multiply by the square root of 32 over itself. The top is just multiplying. The bottom, when you multiply a square root by itself, the square root goes away. And we said to do a bit of simplifying. 32, let's see, is 4 times 8. Actually, we can even do it better. It's 16 times 2. All right, so 32 is 16 times 2. I can rewrite this as 5 times 4 square root of 2, because the square root of 16 is 4, which is 20 square root of 2 over 32. All right, so I would accept that answer on a skill check, but I can do a little bit better. 20 and 32 are even, so I could write this as 10 square root of 2 over 16, and 5 square root of 2 over 8. All right, so the fully simplified perfect answer would be 5 square root of 2 over 8, because you can't simplify that fraction anymore. All right, here's one for you to try on your own. And the fully simplified answer I got was the square root of 3 over 2. But you multiply by the square root to cancel it out. All right, square root of 12 becomes 2 root 3 when you pull out that factor of 4. And then 6 over 12 becomes 1/2, so you get 1 square root of 3 over 2. All right, so now go ahead and practice this. All right, there's a lot to practice for this one skill check, but it's all related to simplifying square roots. All right, so whether it's not a perfect square that you have to kind of pull perfect squares out, or rationalizing the denominator, all right, all this stuff is useful in general whenever you're working with square roots. All right, just go ahead and practice that and then do the skill check when you're ready.